Welcome to Industrial IoT Live Lab here on Industry 4.0 TV, which is a weekly live show designed to help you kind of like get an understanding of the tools and technologies that are out there for you to use to build the connected factory. So thank you for joining us. If you just joined, please just let me know where you are joining from and let me know if I'm audible and visible. Yeah, so what I want to do today is to really give you a basic understanding of the unified namespace. I want to give you like information that you'd require to kind of like get a firm grasp of what the unified namespace is and why it matters. And then from there, you'll be able to visualize or then go on to build your own version of a unified namespace. So we're not going to do a practical demonstration today, but I'm going to take you through all the different concepts and to kind of like really emphasize and explain some of the concepts that I've been getting feedback from the community where it's kind of like not clear to them exactly how that works. So I hope today you're going to get some information as far as that is concerned. So thank you so much. I can see there's people joining in from India, some from Houston. Thank you so much. So this is, again, a new show, Industrial IoT Live Lab, coming from you weekly, every Thursday at 6 p.m. Central European Time. So make sure to subscribe and click on the notification bell if you're new to this channel so that you get all the notifications whenever we go live. Okay, so I think we can get started. Okay, so again, the purpose of this session is to really give you some fundamentals of the unified namespace to kind of like really give you a firm grasp of what the unified namespace is and how it works. So any discussion about the unified namespace really is not complete without using a reference of the traditional way of doing things, because this is basically what the unified namespace is in a way disrupting. So we need to kind of understand what's the current order of things in the manufacturing setup so that you can get an appreciation of how the unified namespace offers a better alternative to building your architecture. So as most of you on the call here, I can see there's some familiar names here. You already understand this Purdue model, right? So this pyramid, which is really is a way of organizing different systems and components within a manufacturing plant in a way that specifies all the different functions that are being performed at each level. So where you have got your sensors and actuators at the bottom of the pyramid, and then you've got your PLCs for interfacing with the sensors and actuators. And then on the top level, you've got your SCADA system, which is really, as the name implies, is for supervisory control and data acquisition, which communicates directly with the PLCs, and the PLCs communicating with the sensors at the bottom of the stack. And then on top of that, you've got MES, and then you have also got ERP, and of late, you have also got a cloud component at the top of that. So this is the Purdue model that was introduced to the manufacturing industry in the mid-90s, right? To have a way of really kind of like organizing your data access or the sharing of data between the different components in your plant. Now, when you are embarking on an industrial IoT projects, the one of the fundamental things that you really want to do is to be able to integrate data from all these various equipment, software, and all that kind of stuff. So the traditional way of really moving data to put it in a position where it is of use for you as a manufacturer. So that is typically in the cloud, where you get to apply some analytics software to for whatever use case you want to achieve for your industrial IoT solution, which could be overall equipment effectiveness monitoring, or you want to do some predictive analytics, or whatever the case may be. Typically, what you want to do is to get your data to the cloud and start to generate insights from there. So based on that, what you need to do is to first of all establish some point-to-point integration between your shop floor equipment and your SCADA system. So this, in most cases, might already exist. So you move your data from the shop floor to the SCADA system, and then from there, the data from the SCADA system will then need to be integrated with your MES system using some point-to-point integration as well. So there are some situations where there's some MES systems in manufacturing, but you'd find that there is not a digital link between these two systems, not to mention that where it exists, it's already in the form of a point-to-point kind of data integration. Same applies when you're moving to the ERP. You've got this point-to-point integration all the way up to the cloud. So as you can see, you need some point-to-point data integration at each level of that hierarchy all the way up to the cloud, which in most cases requires some dedicated engineering, and again, it will require also some custom scripts to join these systems together and integrate data in a way that it could be of use for you to then generate some insights from there. Now, this leads to really a complicated architecture. Even if you do manage to pull this off in this way, it leads to a complicated architecture because it means you've got multiple point-to-point integrations, which makes it easy really for you to integrate your system, to maintain it, or even to make really sense of the data. Because in a situation whereby you've got your data that is moving from a shop floor to your SCADA system, by the time it gets to the cloud, there is no data integrity there. You don't trust that data so much that you can make business decisions based on that piece of data, because it has gone through all these hoops and you don't know what is the current state at the shop floor in real time. You only get the data as it propagates all the way up to the stack. So this is an architecture that really worked in the 90s, and a lot of people in the industry still use this architecture. But when it comes to digital transformation, where you want really to be agile, you want to make data work for you, you want really to put data at front and center of your business operations, this architecture is really limiting in that regard. So this is where the unified namespace comes into the picture. So the unified namespace is an architecture that kind of like disintegrates that whole pyramid and make all these system components into the nodes of an ecosystem that are publishing or that are communicating or sharing data via a central repository or a central store of information. So instead of information moving from the lower level of the pyramid all the way to the top level, information is only shared with a central location such that it is immediately visible to all the other nodes that need to consume that data. So for example, if you've got your PLC there at node 4 and you need to get your information to the MES system, that information doesn't need to go through the SCADA system first. The PLC simply dumps that information into that central repository or central hub, and then immediately that information becomes visible to the MES system. So if the MES system is interested in a certain piece of information from the PLC, it will get that information from the hub there. And so the other nodes that will be interested in that piece of information, they can also get that information there. So basically you've got nodes that are pushing information into a central location, and then they're also consuming information from that central location. So one advantage that is immediately clear from this kind of architecture really is the way that this system is decoupled, right? It means that the PLC and the SCADA, they don't need to know anything about each other at all, right? Because traditionally, if you have got a SCADA system and a PLC system, you need to have a direct connection to the SCADA and the PLC, and have the SCADA send commands directly to the PLC, right? Now you're sort of like decoupling that connection in a way that the SCADA becomes another node in an ecosystem of your manufacturing plant. It's no longer that master that needs to be directly connected to all the devices that it is consuming information from. So that decoupled approach really makes it easy for you to integrate many other components because they're not really directly linked to the physical connection, or they are physically decoupled in a way, right? And this also offers really a scalable system because you can keep on adding all these components here without really affecting the way that information or data is being generated. Because if you were to connect, say, thousands of devices here that are generating information, and you've got some systems that need to get information from that, if you've got 1,000 components that are consuming from one source of information, as you increase that load, it directly affects how that source of information is able to generate information, because now it has to address all the nodes independently, which is kind of like really limiting when it comes to the bandwidth. So this is the idea of the unified namespace: decoupling, disintegrating that pyramid, and making everything a node in that ecosystem, such that they only share information by publishing to that central store of information in a way that it makes it visible to every other participant. And this is really empowering in a way that an MES system that is viewing information inside that central hub knows that this is the current state of every other component that is pushing that information there. So it's easy to make a business decision based on that information, because you know that this is real-time information that is being pushed from the edge. Now, this, for those of you who may be familiar with the IT way of building architectures, you'd be familiar with event-driven architecture. So unified namespace, in a way, is an event-driven architecture whereby the data or information is being pushed as events from the edge or from the nodes that are part of that ecosystem, right? Now, the only difference here is that as opposed to the event-driven architecture, where you only want to generate events that are of like of interest to another application, with the unified namespace, you're saying all the data that is inside a PLC, all the data that is being generated by a PLC needs, whenever there's a change on any piece of data, it needs to be published as an event. So you don't need to wait for a specific event, but every piece of information there needs to be pushed as an event, right? So that is the difference between an IT centric event-driven architecture with this unified namespace. So what it means is that if information is being pushed as events as they occur at the edge, what it means is that that central store of information that is receiving all of these events creates a snapshot, a real-time snapshot of exactly what is the state of your entire manufacturing ecosystem. So if the PLCs are generating information, the SCADA system is generating information in real time, all the events, whenever there's a slight change, that information is pushed to the unified namespace. It means that at any given time, at any given moment, the information that you can see, that you can view, whenever you subscribe to the unified namespace or you connect to the unified namespace, it means that is a real-time snapshot of the current state of your enterprise. Now, that is a really powerful way, really, of architecting a system, because what it means is that suppose you have got like a shipping a module, you've got a software that is capable, that is responsible for managing the shipping of your product. Whenever it's actually consuming information from a unified namespace, it gets real-time information of exactly what is happening on the plant floor. It gets real-time information of exactly what is the status of your order. So it will be able to kind of like interface, for example, with the customer to tell you that, for example, 5 minutes away before we start to ship your order. So that's a general example, but that's the way, that's the power that the unified namespace brings into manufacturing system architecture by giving you that real-time snapshot of all of the state of your business at any given moment. Now, one of the things that you probably wondering about is what is the makeup of that central store of information? How is all these events that are being generated from the edge, how are they organized in that central store of information? Because we're not simply dumping, I mean, it wouldn't make sense to simply dump all of these events inside that store in a way that it doesn't make sense, or in a way that it is not discoverable by all these other participants that are interested in that piece of information. So what you want to do inside your unified namespace to hold your events is to create a structure that makes sense for all the participants of that unified namespace, right? So the best way to really put a structure that makes sense to all the participants of your network is to use the structure of your organization, right? Exactly how your organization is structured as far as laying out all your assets that are responsible for the production of goods and delivery of goods as well. That structure is what needs to be represented inside that unified namespace, inside that store of information. So you're essentially creating a hierarchy, a folder hierarchy, if you will, where all the events are dumped inside a folder that makes sense. For example, here, if the ERP wants to consume information or wants to publish information into the unified namespace, it would publish that event under the organization folder, because this is the folder that all the other components that are part of that organization will be looking at to see what is the enterprise-wide state of things, right? So that's an example. So building that hierarchy, that structure in a way that reflects your organization, gives your information that semantic meaning in a way that it makes sense for all the other components to find the information that they're looking for. So if an MES system is looking or needs to subscribe for information in a particular production line at a particular site, it knows how to navigate, or you as the user knows how to navigate your organizational structure to get to that particular production line where you're interested in consuming or publishing information to. So without even having to have like a manual or a data sheet that tells you that this is where your information is stored, just by the sense of knowing the organizational structure, the semantic hierarchy of your organization, you can easily navigate to find that information. So this is a common store of information that you need to put inside your unified namespace, the arrangement of your information so that it makes sense for all the other participants to consume that information. So now, obviously, for you to be able to, for all these components to be able to share these events or to share this information, they need to have some capability of some sort. What that means is that they need to understand some IoT protocol, because the unified namespace really is an industrial IoT architecture. So if the MES system needs to be IoT ready, it needs to understand an IoT protocol for it to be able to publish information directly to the unified namespace. So if you have components that already understand an IoT protocol, for example, if it's MQTT, then those components, you can directly point them to the unified namespace, which in the case of MQTT will be an MQTT broker. So an MQTT broker is what is going to hold the structure and the events of your business in this case. We're going to discuss more on how MQTT allows you to do that later on in this session. But there happens to be some systems, which is the majority really in industry, that are not capable of communicating using some modern IoT communication protocols. So in that situation, this is where you would use a gateway or an IoT device that sits between your unified namespace and the legacy equipment and does the protocol translation from a legacy protocol, say Modbus, on one end, and then converting that information to, say, MQTT on the other end, and then pushing it inside the unified namespace under a folder where it makes sense for that information to live. So this is a way that you would structure your unified namespace to hold all of your information and events for you to then start to build a data-driven organization, because from there you can make decisions based on all this information that is stored in your unified namespace. Now, I mean, a lot of times you get some people in organizations that ask to say, now, is there a way of standardizing? So I understand that I need to create a semantic hierarchy that represents my organization, but is there a way of standardizing this so that it's easy for me to roll it out into like different factories or even to some customer sites if you need to integrate with your customer systems? Now, there is no fixed or hard and fast rules when it comes to structuring or what's the standard way of structuring the hierarchy or structure of your unified namespace. But the ISA 95 Part 2, the Common Data Model, is a great starting point. Is what is recommended. ISA 95 Part 2, for those of you who are not familiar with it, really it's a representation of your asset model, which uses enterprise, site, area, production line, and work cell hierarchies to reflect the structure of your manufacturing enterprise. So you can adopt this ISA 95 Part 2 approach to create a structure of your business. So I'll show you an example here quickly of how that looks like. So this is an example of a unified namespace enterprise structure. So the example here that we're using is that of a bottling company. So for example, if you've got a bottling company, the top level name would be your enterprise name, right? And then from there, you go to your site. So if you've got two different sites, one in Munich and the other one in Berlin, this is what you put in the second level of your hierarchy. And then on the third level, you have your area, right? So if you've got a filling area, and then from there, you can then put your production line according to how these are arranged in your organization. So you can follow that ISA 95 Part 2 structure to create that structure that represents your unified namespace. And then you can have your components publish events into those folder structures where it makes sense for that information to live. So for example, here you see we've got an ERP publishing a work order into production line 1 in Munich under that enterprise. So that way, it's easy to see the state of the order. Any other component of your manufacturing enterprise that needs to understand what is the current order status in filling line 1 knows exactly where to go based on the bottling company Munich filling area, filling line 1 hierarchy that you've mapped onto your ISA 95 common data model. So this is an example of how you'd structure your unified namespace. Now, so the next question that you'd probably ask here is to say, now you understand that you have got a central store of information that holds all your events and that holds the structure of your organization. Now, the next question is, what sort of store of information is that? Is that a database, or how are you able to store that information? So again, as I mentioned, there's many ways to do it. It could like be a database, but the best way really to do it is to like use an MQTT broker, right? So that MQTT broker becomes your unified namespace. It becomes that central hub that holds the structure and events of your business, such that every other participant that is interested in consuming that information simply needs to subscribe to that MQTT broker, and then it uses the topics to filter through the levels where it needs to access that information, and then it will consume that information and then perform whatever operation it needs to do. And then if it needs to publish information back into the unified namespace, again, it will publish it under that MQTT topic where it makes sense for that information to live. So if you've got any questions, please feel free to drop them on the chat here. I will answer your questions as I go through the slides. So I want to make sure that I get to as many questions from you as possible. So if you've got some questions, feel free to drop them on the chat here, and then I'll answer them as I go through the presentation. That will also help me really provide context to what I'm explaining here. Now, we have talked about the idea that now you've got your central store of information. You have created your structure, and you've ascertained that I'm going to use an MQTT broker to hold that structure and events of your business. But the next question really is, what sort of information, what information do I publish into the unified namespace? So that's, again, it's more of an architectural decision that you need to come up with as an architect or whoever you're working with to put together a unified namespace. But generally speaking, as you would have also seen in, I know Hawker Reynolds talks a lot about the different kind of namespaces that you need to use to as a guideline of what data needs to be published to the unified namespace. So basically, there's three kinds of namespaces, and I'll explain shortly here what we mean by that. There's informational namespace, definitional namespace, and then functional namespace. So these are the different kinds of namespaces that you need to plug into your unified namespace as events. Because here, basically, what is happening is that your unified namespace is basically a collection of small namespaces that you collect from your operations network, right? So for example, if we're talking about informational namespace, basically here we're talking about the data, the actual information of what's the current feed rate and what is the status of the boiler and so on and so forth. And then we've got a definitional namespace. So basically, when we're talking about the definitional namespace, is we're talking about information that doesn't change, right? Information that doesn't change much, right? So, for example, when was this asset installed? And from time to time, you get to calibrate your machines, and you need to log that information to say calibration date on this particular equipment was last done on such and such a date. That information also needs to live on the unified namespace, because the unified namespace, basically the idea is to hold all of this information in a way that all the context can be generated from whoever is consuming that information, because the assumption here is that you don't know what system is going to need to consume that information. So maybe that system needs to understand who actually did perform this particular calibration, on what date and when was this information, that's this particular equipment installed. So that's also another kind of information that you need to aggregate and push into your unified namespace. So again, this is more also of an architectural decision of exactly where that particular information is going to live based on how you understand your organization needs to consume that information. And then there is the functional namespace. So basically, functional namespace is these basic functions, day-to-day functions or industry-wide standard functions that are performed in different manufacturing facilities, right? So these functions normally they are based on KPIs, right? So for example, in maintenance teams always use things like mean time between failures, mean time to repair, or downtime to track the KPIs, the maintenance KPIs. So that information would live under a maintenance namespace, right? So you would have your MTTR live, say, under a production line. Line one, you'd have an MTTR, or under a piece of equipment, you'd have an MTTR. And then again, you've got your production namespace, right? Which is also a different kind of information that needs to live in your unified namespace, because mostly this is the information that really drives a lot of decisions in an organization. People who are sitting in the enterprise who need to make decisions on what to do next, they need access to this kind of information, which in most cases is only available, say, after end of shift, end of day. This information is collected traditionally. This information is collected, put into reports, and then presented to management to say, this is what we did today. Now, that information is not of so much use if it is presented at the end of the day or end of the shift or end of the week. This is the information that is crucial for you to be able to make real-time decisions. So that is why this is the kind of information that needs to live in your unified namespace. So for example, production namespace here, we're talking about the overall equipment effectiveness, the cycle time, production volume. This is the kind of information that is needed to make decisions. And again, architecturally speaking, you've got to determine where this information needs to live. So for example, it will make sense for OEE to live under a production line. So the OEE calculation, if you're reading that information from an MES, or you're calculating it within an IoT platform, when you publish it into the unified namespace, you publish it under production line 1 if it is OEE for production line 1. And then this is where you keep publishing that information. And then when it arrives on the, whenever it's updated on the unified namespace, that information is immediately made available to whoever is interested in understanding if, say, the OEE has gone below 50, or maybe if it has just gone above by whatever margin, or whatever the case may be. Again, in the same argument, quality control, this is kind of information also that could live inside your unified namespace. So as you can already tell, this is a list that is not exhaustive, but designed to kind of like give you an idea of exactly what sort of information would live in the unified namespace. So the next slide here that I have here is to kind of like give you an example, a visualization of what I've just been explaining in the previous slide. So I've just like kind of like picked a few examples here. So you've got your structure that you've built. So if you're using MQTT, you've got your topic hierarchy that you've designed to represent your enterprise site, area, line, cell. And so now you need to then plug that information into that topic hierarchy where it makes sense for it to live. So for example, you can have your profitability. If you want to reflect real-time profitability of each site, you could have that information live under the site, right? So whoever is interested in finding out what is the current profitability for all the different sites, they'll simply subscribe to the site, maybe with the wildcard, and then they can get all this information to find out this is the current profitability in site 1 or site 2. And maybe for each area, you want to be able to kind of like have information that lives in the unified namespace that states or that displays the production schedule for each area. That information, this is the kind of information that could live there. And then for a production line, again, to emphasize, you could have your overall equipment effectiveness living under each production line. And again, because the information under production line could be accessible or could be of interest with people who are interested in that production line, you could have OEE live under area. So the OEE that lives under area is the OEE for all your different production lines. So if you want to find out the OEE for the entire site, that OEE namespace would live at site level. So depending on where you want that information to be reflected or what you want that information to reflect, this is where you put that information on that hierarchy. And then again, within a cell or your edge, you could have also pump information about your pump, and also the definition of information about that pump. And another important thing to mention here is that in most cases, you'd find that whenever you're representing assets within a unified namespace, you want to represent them as instances of models. So if it's a pump, you don't want that information to be, if you've got pump speed or the pump status, you don't want that information to be available as like just discrete text, which makes it difficult for you to filter through and find out that information. So what you want to be able to do is, first of all, before you push information about a specific asset or a specific object within your manufacturing enterprise, you want to create a model of all the different objects. So if it's a pump, you create a pump model, a model for that specific pump type. And then you can create instances of all the pumps of that type. And then when you push information into your unified namespace, you're pushing these as objects so that they can be interacted with in their fullness. Whenever they end up in a database or some analytics application, they are reflected as pumps, not just as discrete text, because then it doesn't make sense for you to then go back to your IoT platform or your cloud platform and then try to make sense of the data again. The unified namespace is meant to be a platform that is complete and makes sense for all your real-time data. And that's important to point out, that the unified namespace is a reflection or a snapshot of your current enterprise, which gives you the state or the real-time state of all the operations that are going on in your enterprise. So Rahid here is saying, is there limitations of characters that can be used? So I suppose you mean the characters of the topic representation, if I'm correct. So basically here, what you follow is the what the MQTT specification allows. So MQTT specification has got a limit to the length of your topic that you can use. I don't have it top of my head what the limit is there, but there is certainly a limit. So you need to refer to that and make sure that whatever hierarchy you create is within that limit as far as MQTT specification is concerned. So Amal is asking, what is birth and death certificates? Okay, so basically birth and death certificates, so even though it's not related to unified namespace in this instance, is a way of managing the session state of all your components within an MQTT network. So you want to be able to know what is the current status, especially if you're operating in a SCADA environment, you want to know what is the current status of that pump. Is it online? Is it on? Is it off? What is the current status of that line? So having that pump announce itself when it joins the network by publishing a birth message. If it's spark plug, that birth message will indicate all the metrics that that pump is going to be publishing. So that is crucial for that pump to be able to publish a birth message that notifies all the other participants, or importantly, the SCADA system, that it has joined the network. And then when that connection is abruptly disrupted, the broker will then send a death certificate to all the different participants to notify them that the pump is no longer online. So this is crucial to know within a SCADA environment what components are online and what components are offline. So I hope that answers your question, Amol. Now, again, we spoke about this idea of creating namespaces, this idea of arranging or modeling your data and creating instances of objects so that they can live on the unified namespace. But the fact of the matter is that, as most of you on the call would know, that the plant flow information coming from PLCs is mostly low levels of abstraction, right? So before that information can be pushed into the unified namespace, it needs to be massaged, as it were. It needs to be operated on to make it suitable to pushing into the unified namespace, or to, like, for example, the example that I gave about a pump. If you want to create a model of a pump, so you now need to create use an IoT platform that allows you to create a model of the pump, and then create instances of that model, and then use a legacy protocol to say Modbus to read a specific tag, and then map it onto that instance of a pump. So I know, for example, Ignition SCADA uses user-defined types to allow you to create those models and instances before you publish them into the unified namespace. So whatever IoT platform you may be using, you need to use it to create those models and so on and so forth. And additionally, there's a lot of challenges also with plan flow data. Some of it may not be normalized, right? So maybe one platform is using a different time format, another PLC is using another different time format. Now, you need to be able to kind of like normalize this data so that it all reflects the same time, because it won't make sense for you to publish information into a unified namespace regarding time, and yet that time is in different formats, because you are not going to interact with your data intelligibly if you have your information arranged in that way. So you want to be able to normalize that data to make sure it is consistent, your data is consistent, because again, the unified namespace is designed to be the one-stop interface for all your real-time data. So you want to make sure that before any data is pushed into the unified namespace, it is consistent, there is consistency, so that you can get the best value out of that. Now, in transformation, again, so there's calculation that you may want to do, because in most cases, raw information may not be what you are really looking for. So maybe in your organization, it makes sense for you to calculate what is the average production volume for the past 12 hours. So maybe that makes sense in your particular organization. So you want to kind of like also transform your data to reflect that, and then push it into the unified namespace, where it is going to make sense for that data to live for whoever is interested in that piece of information to find out. So again, an IoT platform is crucial there. So as you can see, an IoT platform is also a central piece of a unified namespace, as it is responsible for creating all these data structures, even creating all these hierarchies, and then pushing those into the unified namespace. I'll give an example of Ignition again. If you're using Ignition MQTT transmission module, which allows you to create a hierarchy and plug your text into that, and then when it is published to an MQTT broker, it is published based on that hierarchy that you're creating within Ignition. So that is the unified namespace that you then push, and then that structure lives inside that MQTT broker, and you can also consume information from it. So this whole business of contextualization means that since you are not pulling information only from PLCs and historians, you might be pulling information from some databases. Maybe you're pulling information from a SQL Server database, where you've got information that you need for you to add context to whatever data before you publish it into the unified namespace. This is again the role of the IoT platform, to help you connect to all these other sources that allow you to create context and make sure that you create a valuable information, so that it's not just raw data that lives in the unified namespace, but rather it is useful information that allows you to create a data-driven enterprise, because the end goal is really for you to be able to look at the unified namespace and make a decision in real time. So that information needs to have all the context that is needed for you to make that decision. So Rakit, I see you've got another question. Can you tag within the unified namespace? Can you please elaborate your question? I'm not sure I understand what you mean by can you tag within the unified namespace. Now, the unified namespace, I mean, I've been talking about how the unified namespace is a snapshot of your real-time data. It's like the store of your real-time events across your entire enterprise. Now, one of the common questions is, is the unified namespace. What about historical data? Because in most cases, you need historical data really for you to make sense of the data. So the unified namespace can be a source of data for historians. So for example, here, what I'm showing here is transactional data, whereby the information that is being generated in the unified namespace as events can be used as a trigger, by example, an IoT platform to then perform some transactions. So I'll give you an example of this. So if you say, for example, if a certain event occurs, you want to say generate an invoice, or you want to say perform a certain transaction that lives outside of the unified namespace, but a unified namespace can be used as that trigger, as that source of events to then trigger those transactions. So you can still, this is how transactions can become part of the unified namespace. They don't live within the unified namespace themselves, but the unified namespace can act as a trigger to generate those transactions that don't normally live within your unified namespace. So since the unified namespace contains the current state of your business at any given time, and it's that snapshot of your business, a lot of this information as it is can be persisted into a data lake. So for later retrieval. So if you have, say, some machine learning use cases where you need some historical information, where you need some data for the past 2 years, or for however long you need that data you need to find it from a data lake. That could be information that is coming from the unified namespace. And the advantage really of having the unified namespace provide that data to fill up your data lake is that the unified namespace, as we have already explained, that it is information that is already been contextualized. It is information that makes sense. So it's not a situation whereby a lot of companies, what they do is they simply connect PLCs, different systems, and then send all of that information to the data lake. And then they then start to worry about how to then start to build models out of that data. So that is an added challenge really for making sense out of that data. So what you want to do before you even persist your information is to kind of like really try as much as possible to make sure that that information makes sense, that information is contextualized, which is really what the unified namespace is for. And then that information is consistently being persisted onto a data lake. And then from there, if you need to use some time series analytics app, you can then query your data lake to present that information to you in a time series manner. If you want to use a structured analytics application, you can then access that information from a data lake in a way that makes sense for you to present that information structurally, right? So the unified namespace still is capable of historizing all of that information. It is not a store of information itself, but it allows you to store information elsewhere for later retrieval. So again, there's the idea of a unified namespace is that you could have different local UNSCs in different areas, and then all of them pointing to a central unified namespace. So basically, you can have a unified namespace for each site, and then you have all the sites publishing all of that information to a central enterprise unified namespace, where all of that information is consolidated. So if a certain piece of information or certain piece of software is within a site and typically not interested in enterprise-wide information, it would look for information, or it would reference information from within its local unified namespace, right? But if you've got an application that needs to access enterprise-wide information, then it subscribes to the enterprise unified namespace to get information about all the 3 different plans that you have in your organization. So again, MQTT so there's many ways to really implement a unified namespace, but as you, if you are familiar with the concept of unified namespace, or if you've heard about unified namespace, most implementations are MQTT. So MQTT is basically kind of like the native protocol for unified namespace, primarily because of these four main features or capabilities, which again are more espoused in the teachings of Walker Reynolds when he talks about all of these items, where he mentions that it is an open architecture. MQTT is open. So because in a unified namespace, you want all the participants to be able to consume your information. So it doesn't make sense for you to use a protocol that is closed source. So only a limited number of components are able to participate in a closed source ecosystem. So you want to make sure that whatever protocol you're using for a unified namespace is open, which is what MQTT is. And then lightweight, again, this is information is being pushed from the edge. You want all of that information to be lightweight. And report by exception is also very crucial because now you don't want to consistently poll your sources to get a notion of real-time snapshot. You want that real-time snapshot to be a result of a report by exception, events being generated as and when they occur, right? So now the responsibility of generating events is delegated to the edge component. It's not the responsibility of the SCADA system anymore, or of some host application that needs to monitor and consistently seek for information, ask for information. Rather, information generation is the responsibility of the edge component. So that makes it easy for you to replace and change your system and be flexible about how you go about building a unified namespace. So again, what we've been talking about is MQTT, and also if for those of you who are not familiar with Sparkplug, just a quick brief here about Sparkplug. Sparkplug basically is a specification on top of MQTT that defines a consistent topic namespace, which is crucial for industrial interoperability. It defines a consistent session state management, which goes to the topic of birth and death certificate, because MQTT has got a death certificate mechanism, but there's no guarantee that a device will implement that. So Sparkplug session state management is a way of enforcing a consistent way of implementing a death certificate. And then on top of that, it adds birth certificate, which are end birth and end death, which is also crucial for interoperability. And then also a consistent payload representation, which allows you to really easily exchange information. If I'm sending information to you, you need to be able to understand if that information is an integer or that information is a float. And so if it's a SCADA system that is receiving a birth message that is saying, I'm a pump, I'm going to be publishing to you the pump speed, which is a float, and I'm going to be publishing to you the pump status, which is a Boolean. So this SCADA system needs to understand that upfront and be able to interpret what it means for a data to be Boolean, or what it means for a data to be a floating point value. So this makes it easy for you to kind of like really use custom drag and drop interfaces to build the system that are easily interoperate, because they already understand the data types that are used by each system. So again, using flat MQTT topic structure, I think we've discussed this before. This is precisely how you'd structure or how you'd map your ISA 95 topic namespace using a flat MQTT topic structure. So by flat MQTT, I mean MQTT that is not enriched using MQTT Sparkplug. So this is like your pure MQTT. This is typically how you'd structure that. So when it comes to a Sparkplug, if you want to use Sparkplug to create a structure for a unified namespace, this is where you are supposed to use these elements that are provided for you to kind of like reflect the structure of your organizational hierarchy. And you have your group ID, edge node ID, and device ID available for you to represent that. And as you can see, you have got enterprise site and area only represented there. And in cases where you might not have device ID, you've got enterprise and site. So this is kind of like a common setback as far as Sparkplug is concerned in the community. And Lucky enough, we have got some members of the community who have come up with some ways of working around that, and this is mostly captured in the approaches that were popularized by Matthew Paris. This one was popularized by Matthew Paris. There's another one was popularized by David Schwartz, which I'm going to talk about in a second. So basically here, what you're doing is you use the group ID and delimiters, your colon delimiters, to peg your entire organizational structure within the group ID, which allows you to fit the structure of your organizational hierarchy. But again, Sparkplug is simply a specification on top of MQTT, so which means it is still subject to the limitations of the length of the topic. So you need to be mindful of that when you do that. So, and using this format, it means that you have to have an IoT platform that is capable, when you receive this information, you need to be capable of then stripping out these colons and then republish that as a flat MQTT topic, because if it's like this using colons, there's no way of filtering through your data, because Sparkplug still sees that as just group ID. So you need to unpack that and republish it into the broker as a flat MQTT topic structure. So again, this is another method with if you want to have a different way of approaching the UNS structuring, if you don't want to use the Paris method, which allows you to put delimiters, is that rather you use multiple brokers to segment your unified namespaces. So you create a local hierarchy in an area or in a site or whatever the case may be, and then you publish that to the broker, and then you have got your IoT platform, which is subscribing to receive that information from the broker, and then it creates its enterprise hierarchy and then puts that information where it's supposed to live, and then that information is republished back into the enterprise unified namespace, and then you end up having your entire enterprise organizational hierarchy reflected in your enterprise unified namespace. So that's also another way of really kind of like creating a larger organizational hierarchy using MQTT Sparkplug as it were. So this is this brings us to the end of this session. So I have a book, an essentials book that I put together that kind of like really explains also the concepts of unified namespace. If you want to check it out, I'll also put the link in the description of this video, which you can refer to later. So if there are any questions, please feel free to post them on the chat here. I think we've got a few more minutes to go, so I'll be more than happy to take some questions. So if you are joining us for the first time on this channel, feel free to subscribe to the YouTube channel, and also make sure that you switch on your notifications, because again, this is a weekly live show. We're going to be doing this every week, talking about different tools, exploring different tools and techniques. We're going to be bringing in different experts from different industries, different companies, different protocols, different architectures. So look out for that one. So seems like there are no questions. If there are no other questions, so again, Rakit, can you tag within the unified namespace? So I'm still not sure about the question tagging in within the unified namespace. What you mean by tagging in the unified namespace? So if you feel free to send me a message on LinkedIn. So Alessandro, you are saying, okay, what is the database behind the unified namespace? So again, the database, the unified namespace is not a store of information as it were, right? So rather, if you're using MQTT for your unified namespace implementation, your broker becomes that central piece that sort of like stores the current state and structure of your business. So if you want to find out what is the current state in production line 1, you simply subscribe to the broker, filter through using the topic hierarchy to find out exactly what is going there. However, if you need to, that information can still be persisted in a separate database for later retrieval as historical data. That this is where you can use a historian, a normal historian, whether you're using Influx DB time series database or you're using something like an industry historian like Canary, or you want to store this information in a data lake so that you've got you can store all kinds of information, time series, structured, unstructured. You can also use a data lake. So the unified namespace basically acts as that conduit that allows you to persist well-structured information in a data lake for later retrieval. So the unified namespace itself is not a database. It is a snapshot of your current state of your business. It gives you that current snapshot, current status, and then from there, you can then persist that information in an external database system. And maybe if you want to use a streaming platform like Kafka, that information can also be put in a Kafka. But again, Kafka is not also a database, but rather at least it allows you that retention period way to store your data and allow your enterprise applications to consume from there. But if you want to persist your data for like long-term storage, for machine learning models, for building your advanced analytics use cases, you're best served by persisting that information into a data lake and then use some analytics applications to then use that information to generate some insights. I hope that is clear. Okay, so thank you so much for joining us on this session. Really appreciate your attention here. Again, next week, make sure to join. I'll really appreciate it if you can join us next week again. So thank you again and goodbye.